Dr. Kevin MacDonald. Kevin is president owner of Beton Consulting and also a professor, and a great resource for all of us that like concrete and always have something interesting to find out from Kevin.
So when I was flattered to be asked to give this presentation, and to recognize many of Bruce's contributions to the construction world, particularly concrete construction, but also some conceptual things. And Bruce doesn't know this, but my students hate him. And that's because they are currently, and as I'm not there on tomorrow, they have their examination on design of reinforced concrete beams. And each one of them is going to design a beam to resist a particular loading condition, and everything is great. And then Bruce will know where this comes from because it comes from him. I will assign a grade, a sliding scale based on the cheapest and easiest to build, and go downhill from there. More expensive, more difficult to construct is going to be terrible and bad. So I've been coming to ACI meetings since the last century. It's a good way of saying things, and it's always dangerous when you meet your heroes. And I met Bruce and Ward the first couple of times I was at ACI, and I was in awe. I mean, these are people who I had been reading. I told them since I was a kid. Ward said that made him feel old, and I said, "That's all right, Ward. You should feel old. You are old." Bruce not so much because he was closer than my age. My father was also a concrete addict. And a lot of my work has been in dealing with helping out the contractor or helping out the ready-mix producer to meet the requirements of the project, and to try to do so in a logical way without having to cite chapter and verse or Holy Writ and bring in the specification, bring in an ACI document that says this is how you do it, because sometimes ACI documents aren't as well thought out as perhaps they should be. But I also know, and I've told Bruce this a couple of times, that contracting is easy. I don't know why everybody complains about it. It's the easiest thing in the world. Engineering, we have to do all sorts of things. We have to worry about loads and people we're never going to meet, and uncertainty and tolerance. Contractors, dead easy. You just have to win bids and then perform them at a profit, right? If you do those two things, or if you don't do both of those things, then it doesn't matter. And if you do both of those things, then it also doesn't matter. This is so simple. And often the problem is that you've won the bid thinking that it says one thing, and then you try to perform it at a profit, and you find out that, well, there's some expectations that you may not have been aware of. I see there's a fellow here in the lower left-hand corner with a beard. He doesn't have a Hawaiian shirt on. He's wearing a Roman-style Hawaiian shirt. It's made of plates of steel. But this is on Trajan's Column. They're building the bridge across the Danube. Up in the corner, they're mixing concrete. The architect and the engineer have come to the site, and they are looking up for inspiration. The last thing they want to do is look down and see how out of tolerance construction is being made. One of the things that Bruce contributed to this process of concrete construction is the understanding of who's responsible for what. If you have a problem, and problems occur in construction, is your repair a betterment? Are you repairing something because it wasn't constructed properly, but you're building it to a higher standard than you were originally specified to meet? That's a betterment, not a repair. The other that we do all the time, we see this all of the time, is the passing of the requirements of the building code, ACI 318, back to the contractor. It's totally inappropriate. Bruce has written volumes on that very topic, because we have a bunch of unwritten owner requirements that we only find out about during the execution, during phase 2. You've got the bid, but you wish now you didn't. You've won the project. You have problems with longevity, with appearance, with cracking in the structure, curling of slabs, shrinkage of the concrete, all of these things that were implied but not stated in the specification. And to make sure that it gets covered fairly. We also have a lot of expectations from the contractor. And many times we're not as eloquent in describing these elements as the contractor, but we are much more profane in doing it. So the owner very rarely uses the proper word lubricants to get the message across. A lot of cases, workability, finishability, strength gain, cold and hot weather, Bruce has worked on all of these aspects to get an understanding between the contractor, the designer, the subcontractor, the material supplier as to what it is that we're actually going to try to execute. And he hasn't done so to the sole benefit of the contractor. Mike Ahern quite clearly stated that it's always to do what's right. And we don't use this type of information. We don't use anecdotal evidence that once upon a time this guy put some fly ash in my concrete and the concrete opened up and I could see straight down into hell and there was a devil and he was eating fly ash and I knew it was a problem and that's why the issue occurred. Instead, we use data. And here's some perfectly reasonable data. This is the total U.S. highway fatality rate and the fresh lemons imported into the USA from Mexico. So clearly, whatever is being drunk with those lemons is causing fatalities. This is the famous causation and correlation. One of the things that Bruce worked on was architectural concrete. Sometimes concrete was not meant to be seen. This is after the brick facade has fallen off the building during the fire. We can find out that we could probably figure out the method of construction and where the concrete placements were at this location. But we have to remember that people no less than Bryant Mather tells us that we have failures in construction that occur only for two reasons. Number one is the contractor didn't follow the specification. Very rarely do we talk about the second part. The specification was in error. It couldn't be constructed the way that it was written. And that becomes a problem. And frequently, Bruce had this kind of success when dealing with authority. That you could encounter the authorities and demonstrate to them factually that what was being specified, what was being requested was an impossibility. I left this one up here in its entirety. This is a quotation from Bruce's article on Beware of Lean Green Concrete. I've done an awful lot of work in concrete with almost no Portland cement in it. But I've done that work cognizant of the fact that you actually have to build with it. I can make stuff in the lab that is fantastic. It has great performance, it has high strength, it slices, it dices, it makes julienne fries, whatever you need that concrete to do. But you have to cure it at 100 degrees Fahrenheit for 7 days. How you're supposed to do that on the site? I'm just a lab guy. That's not my problem. That Bruce never took that approach. Bruce took the approach of saying, you need to understand. And often what happens is that we will develop a mixture, or I would develop mixtures when I was at Semstone that would have very little cement in them, and someone else would try it without understanding the admixture packages that were going into making it work. And then 3 days later, when the concrete won't set, they call up and say, your mixture worked. And I said, what do you mean my mixture? It came out of someone else's ready-mix trucks. But we got to fix that anyway. So you need to be careful. And this is the type of advice, the type of practical, sound engineering judgment that we all need more than ever as we creep towards a situation where we use as little clinker as we possibly can. And there are going to be consequences. And we're not changing away from Portland cement because we think that it doesn't work. We're changing away from Portland cement because there are political ramifications and emission ramifications to its use. So we need to understand how they're going to work. Where did all of this come to? It came to this type of document. When I was running NRMCA's P2P committee, we needed to have some documentation that was more than just, we know what you need, we'll put it into the concrete, you can trust us, right? That violates number 2. You've got the bid, but you really don't want it. I put this up to scare Bruce. I think this is a very nice archaic antique, once used to sell more than a century ago to measure some property of concrete that isn't really very important. And we still use it today because we need to have something to do with those broken tape measures. If we don't have, otherwise we'd be throwing them away. Imitation being the sincerest form of flattery. When I've written specifications, I write them that the slump shall be consistent with the method of construction with no visible signs of segregation, and we describe segregation using an ASTM test method. And it's very interesting to watch the reaction of the testing agency that says, well, what is the slump supposed to be? Whatever the contractor needs it to be, who cares? Well, how will we know what we're measuring to? Well, the specification goes on to say you have a 2-inch range. It'll be on the ticket. Well, how will we know that that's the right number? Yeah, you're not getting the whole picture here, right? I mean, the slump is very good if you're a ready-mix producer. Use it all the time. Are we making the same concrete? Because if we don't have the same slump coming out of the plant and we think we made the same concrete, we're bullshitting ourselves, right? But if you're now going to place the concrete, if it's a 2-inch slump or a 12-inch slump, I guess if you're a Puritan, a 2-inch slump means that the laborers will work hard and they'll be tired and won't go out and do any carousing at night, and that will be good. Although laborers that get tired and they use that as an excuse not to go out drinking usually aren't very good laborers, in my experience. Right? We still see specifications written like this despite the work that Bruce has done. But Bruce has shown us the light that we can all go along. You can add high range water reducing admixtures being added at the site. It's the dumbest thing you can do. It's the best way to get air into concrete that's not air entrained. Can't we have the slump as required? All kinds of problems with this construction. And in sometimes it's because we rely on the quality of our concrete based on measures that are not good measures of quality of concrete. I counted here. You can see I've labeled them for our use. This is a 6-sack mixture, so you don't need to worry. It's and you can see that there's a couple of things going on here. One is that the batchman and the yard man are getting ready to mix, and the contractor's been worried about yield. That's why he's back there measuring. He says, those guys are way too happy. There's something going on. We have to understand all of these tolerances, and a 6-sack mixture is a silly way of doing things. Similarly, self-consolidating concrete isn't always magic. A lot of concrete is done with a tolerance. The nice thing is you can find your pencils afterwards. There might be a little bit of steel in this structure. And no matter how good you are with self-consolidating concrete, you probably can't make that work. I wish this was other than a real project. You need to clean up your site. Otherwise, you find out where all that wire that you cut is inside of the forms. This is architectural concrete, right? We have a lot of definitions of concrete exposed to view. And finally, if you don't understand the placing techniques, there's no magic. This was Bruce's great contribution, was to continue to apply data and reasonable engineering approaches to solve problems. These are people who believe that self-consolidating concrete was somehow magic. It isn't, as you can see. Bruce, working together with Ward, would routinely challenge the orthodoxy in this industry with actual data. How to plan a cold weather concrete pour is a fascinating article. It's getting older. I mean, it's not Bruce old, but it's old. And you can read it, and it's still very useful. You can barely make out free fall of concrete. Free fall of concrete is something that the specification will say concrete shall not be allowed to fall more than 6 feet. If you read Bruce's work, that seems to be a fairly arbitrary number. It's almost as arbitrary and as it's still in ACI 306 that the concrete can withstand one freezing cycle once it reaches a strength of 500 psi. Because why? Because 500 psi sounds like it's a nice round number. Does it come from anywhere? We're probably not. But let's take a look at some of the things that Bruce has contributed to. If we go to hot weather concreting, it will tell us that one of the ways to avoid plastic shrinkage cracking is to erect a windbreak. This is a table from one of Bruce's publications showing you that the windbreak type that you're using and how high the windbreak has to be in order to, which is H, to protect a zone of width W. And so it points out correctly that to protect a 30-foot wide placement, you need a 4-foot high piece of plywood or something else solid. What that's anchored to when the wind is blowing at 60 miles or at 50 miles an hour could be very interesting. So this type of information and where that windbreak really protects leads us to very practical solutions of saying erect a windbreak. It sounds like a great idea, but what is the geometry of that windbreak? Bruce did the calculations. Massive embedments, still a big problem. We watch in Minneapolis every winter people going around with a weed burner trying to take the temperature of steel in the air at 20 degrees or the air at minus 20 degrees with a weed burner. And it probably gets up to above 32 degrees for a few seconds, but it rapidly radiates the heat away. Work done very recently to show that a number 14 bar, for that matter, anything smaller than a number 11, are not massive embedments. They don't need to be heated. And this was done not because it's easier for the contractor. It's done because we're wasting time and wasting effort and heating up bars that are going to heat up in the concrete anyway. We have lots of problems with our current system, and Bruce has been able to help us out a great deal, right? The current system works well. The specification clearly lays out everything you need. A submittal shows that the contractor follows those requirements. A testing lab of competent testing is hired to check what's being supplied, and there are never any problems, and everything is great, right? And Bruce is among the first people and the leading person to be showing a highlight to that's not the case. How often have you been exposed to a specification that gives you a requirement for modulus of elasticity? This is the equation that is found in 318 for modulus of elasticity. The equation would be those straight lines, not the very large scatter of a couple million psi that occurs in all of the data. Right? We have performance-based specifications. Want my concrete to pour like Niagara, have the strength of Gibraltar, right? There you go. What more can you? What do you need it faster? Or sorry, do you need it louder or do you need it slower? This is a contractor who read the specification that said water shall not be added to the truck after batching. Right? I'm in compliance with the specification. This is a labor-saving placement where we use concrete, green concrete, that's going to set so slowly that we can take a break in the middle of the pour for lunch because it doesn't matter. It's not going to set for the next 4 or 5 or 6 or 7 days. So what's the difference? Architectural concrete is somewhere else. Bruce did quite a bit of work. That was what does concrete look like, and what concrete is exposed to view. Those of you who don't know, the definition of architectural concrete in the CT is concrete that will be exposed to view. So this looks nice to me, but you could often get in trouble. This one is not so much. It's a very normal thing to see in a concrete placement in this exterior surface, but this is the material that was removed. And then we don't always understand what it is that we're doing. If we read this sign, it's very clear. Do not touch. This wall is finished product. Do not lean material against or fasten anything to this area. And they have they followed their own rules. They have taped that to the 2x4 that's been set into the column with nails. Right? This is the kind of cognitive dissonance that we need, that we have always needed a Bruce to be telling us about. And finally, we all know that there are really interesting people in the world, and Bruce is one of them. It's been my pleasure to work with them on committees and things, and to talk with them on the on various issues, and I was very flattered to be able to give this presentation. Thank you, Bruce, for all of your contributions.